Alright, this is AP Physics, Unit 3 test. Alright, so number 1, K final equals K initial plus potential initial. So half of mv squared equals half of mgr, because v equals gr. The v equals the radical of gr, which I substituted in. And the square root is canceled out by the square. Plus mg 2r, the full length of the diameter, not just the radius, which I step on, equals, cancel out the m's cancel, and add it all together. So v final equals radical 5gr d. Right, number 3. So the power supplied by the lifting force, power equals energy over time, seconds. So in the answers, looking at the answers, mgh, potential energy, gravitational potential energy, is the only energy in all of them over time, which is seconds. So B is the only possible answer. Okay. So for number 4, acceleration equals v squared over r. And then we just flip it to get v equals radical ar. Velocity, radical 300 times 3. So the velocity equals 30 meters per second. And in the question, it says, at the instant the car's velocity is directed due east, so it's going clockwise, and the acceleration is south. So let's do image in the bottom corner there, displaying. Alright, C5, 5. So it's the mass of 2, velocity of 2, minus mass of 1, velocity of 1. They're the same velocity. So it's a momentum equation. And m2 minus m1, E is the delta P. I don't know, I missed that, man. 7. Alright, 7. Force equals ma. So with all 3 m's, it's 3 ma. And so F over 3, you move the 3 over the other side, F over 3 equals ma. Ma equals F net, so F, the total force is F over 3. Alright, let's see. Let's see, 10. Alright, 10. This is a momentum equation, so it's m1 v naught, and then final speed with 4 kilometer mass is, alright, so since the first block is the only one moving, the second block has no velocity, so that's 0, so m1 v1 v naught 1 is 24 equals, and then since it's a perfectly inelastic equation, because they're sticking together, m1 plus m2 equals v final. So 24 equals 8, v final equals 3 meters per second. Alright. Number 11. Alright. So m naught v naught is cosine of 60 plus m naught v naught cosine of 60. So you just add them together. Same velocity equals 2 m naught v naught final. M naughts will cancel out, leaving you with 2 v naught cosine of 60, and then 2 v naught. 2's cancel. V naught final equals v naught over 2, because cosine of 60 is 0.5, so just v naught times 1/2 v naught over 2, right? 15. I don't know how well I'm doing this camera thing. 16 E. Alright. So E, following graphs show the greatest cause in kinetic energy of an object is from x0 to x equals x1. So greatest change just in total for time is E. 17. Alright. So centripetal force. Friction is negligible. 1 kilogram motion. The centripetal force. So centripetal force equals v squared over r. So or centripetal force equals half of kx squared. So centripetal force equals 3. Centripetal force equals kx. Those aren't right. Alright, centripetal force. So it's 100 because the spring constant listed up here, 100 newtons per meter, and then the distance 0.3 stated here. So the centripetal force is 3. So B. Alright, 17, 23. Jeez, I missed a little. Alright. So the ball at position Q, the direction of acceleration is upward. Since the velocity is to the right, the acceleration is constantly changing inward. And at point R, the velocity is 0, so the acceleration is just gravity. So C, 24, no, just 24 A. Let's see, 25. All right, so just find the force of the block. On 25, just find the force. So you find the angle first, which is inverse tan 3/4. Gives you that angle, which is needed. So find the normal force, or those will cancel out and equals. All right. So y components. So you're finding the normal force. Normal force is mg cosine theta, which is, I don't know. I did solve my calculator. Let's see. It's fine. So n equals mg cosine theta, and then you plug the n in and find the x value, which will give you the force needed to apply. So mu n friction plus mg sine theta will give you the force needed, which is 42. So n would have to be what? 10, 3 force. I can plug it in right now. Fine. 26. So for 26, you just found out I plugged in the different values to try and equal the 6 sine of 53, and I found out that the 8 meters per second sine of 37 equals the 10 meters per second, which you started out with up at the top here. Right, number 27. Alright. So, the particle is released from R naught. Its speed of position 2 R naught is most nearly. So we know that at that point, so we know at R naught up in the graph, it starts out at 2 U naught equals half of mv squared. And since 2 U naught, what's it called? 2 U naught equals the, what am I thinking? Why am I doing this? Draw a blank. Anyway, so 2 U naught is the starting point, so multiply the 2 both sides. 4 U naught equals mv squared. Take the divide by m, and then find the radical, and you get 4 U naught over m, all in the radical. Alright, so 28, you just take the derivative of br to the negative 3 over 2 power, which gives you negative 3 over 2 br to the negative 5 over 2 power, which is a last two. Let's get this going. All right. Again, you're gonna find the derivative of 29, which is negative mg plus half of k2x. I forgot a negative. Put that in parentheses, negative. Anyway. All right. So the half and the 2 will cancel. Plug in the negative, and you get mg minus kx, so e. And then last one, see where we started. Which one? What do we know? So, all right. I did this a couple times. I don't know what I did on the test. So the final velocity. So we're gonna find the final velocity at this point first, so that we could use the momentum equation to find out the initial here and then the final here. So to find the initial at this point, I used v squared equals v naught squared plus 2a delta x. So the final velocity at this point is 0, so v naught squared plus 2 times negative 10 times 10 gave me what? Jeez. Oh, scratch that. What am I doing? Did I try and find the t? Alright, yeah. So, scratch that. Don't ignore that part. Jeez. I did so much stuff trying to figure this out. Alright, so here, we'll start here. It's this row right here. Delta y equals v naught t minus half of gt squared. Plug in the numbers, so the delta y change in distance is 20 equals half 10 the acceleration t times t squared. You get 2, because 20 divided by 5 gives you 4. Radical of 4 is 2. So you plug in that t that you got in the previous equation. Delta x equals v naught x t. 10 delta x equals v naught x times 2. V naught x equals 5. So from up here, you get the initial. You get the weight of the bullet, weight of the block, and the distance the block travels, both directions. And you're trying to find the initial velocity of that bullet. So you get mass 1, the mass of the bullet, times the v naught 1, the velocity of that bullet, equals a perfectly inelastic equation. So 0.012 plus 1.2, so 1.212 times 5 divided by the 0.012 gives you 505 meters per second. D for that.